one of the concerns with, in particular, the solution to the quote unquote solution to the binding problem, which is based on synchrony. Um, I mean, for context, a lot of neuroscientists believe this. It's like, okay, why is it that this neuron that encodes color and this neuron that encodes shapes are able to aggregate their information together and create a colored shape? They claim that it's because, well, those two neurons fire simultaneously, and that simultaneity, that synchrony, somehow creates the binding. I think there's like a lot of like conceptual reasons why this doesn't make sense. Definitely not as a solution, but there's like, I think, like a very, very big hammer just from physics, which is the fact that there is actually no objective, plane of simultaneity. Like there's just no matter of fact of like whether they fired simultaneously or not, because simultaneity depends on your frame of reference, like how fast you're moving and in what way. Now, movements, according to relativity, essentially they do this thing which is called the Lorentz transform, which is kind of like squishing and shearing the plane of simultaneity. But that type of transformation, it can change apparent distances, and it can change things such as like area and angles, but it doesn't change topology. I mean, if you think about it, the very definition of like what is a topological class has to do with things that remain invariant no matter how much you stretch or deform, as long as you don't cut or bind, right? Like, and essentially the Lorentz transform, the transform that you get from relativity, leaves the topology intact. And that's why the topology of the field is frame invariant. It doesn't matter how you look at it and from what angle, it has the same topology. Yeah, I mean, I guess like to wrap up in that front, yeah, I mean, also the fact that like the topological pockets are spatially extended allows them to actually also have like more causal power, because essentially every component of the pocket can essentially kind of like carry the same message, carry the same program for the same reason that like every point in the guitar approximately is essentially vibrating in the same way and reflecting the entirety of the guitar. So the behavior here is that, yeah, like everything that is touching that pocket is kind of interacting with the same object, even though it's like spatially extended. I mean, I think like there's like emergent theories of consciousness, which is like, okay, at some level of complexity, you have this new phenomenon that is like qualia and bound experiences. It's completely strange and mysterious, and I think like unscientific. I mean, the idea that like all of a sudden, at a certain level of complexity or scale, you would have like something that is like ontologically new emerge. So I don't think like strong emergence really makes sense unless you invoke something like God or something, some kind of interpreter, that says like, oh, okay, the conditions here are met. Let's like add a new entity based on that.
It's like saying when you have these conditions, then you get electromagnetism. Like electromagnetism is born all of a sudden.
Exactly. I think it doesn't make any sense. Topological segmentation is actually entailed by the laws of physics. I mean, like the cohomology of the electromagnetic field is an implication of Maxwell's equations, in the exact same way that light, electromagnetic radiation, electromagnetic waves are hidden in but implied by Maxwell's equations. I mean, just a very small tidbit of history here. Actually, the Maxwell's equations were figured out before it was known that the electromagnetic field had waves. And then, like, they mathematically found, like, oh, actually, the math show that under some conditions, waves will emerge out of these. So in the same way, yeah, like the topological pockets are implied in the math. They're not, for that reason, like strongly emergent. They're actually just an expression of the very math that we already know of.
And so how does this also sidestep the hard problem of consciousness?
Yeah. So these requires essentially a monism slash panpsychism. So like the hard problem of consciousness here is sidestepped by essentially positing that the one thing that exists is this gigantic field of consciousness, as opposed to like, hey, how do you get consciousness out of matter, essentially?
And how does this also prevent the complication of epiphenomenalism?
Yeah, I mean, essentially, in this case, the actual shape of your consciousness clearly has behavioral effects because the actual shape traps energy, vibrational modes, and then like that can be useful for computation. And so you have this actual connection between the phenomenology and what the phenomenology is doing, as opposed to requiring these leaks, extra physical map between them. And just to wrap up there, and to put it in context, I mean, I do think it is a new, meaningful, and non-trivial contribution to the conversation because there's like other solutions to the binding problem that just don't hit all of these points. I mean, like panpsychism traditionally is like, okay, let's assume each atom is made of qualia. Well, then David Chalmers very helpfully pointed out the combination problem for panpsychism is like, yeah, sure, like atoms are made of qualia, but then you still haven't solved like how they're put together, right? Like what makes that happen? Or let's say like there's some people who say like entanglement, quantum entanglement is the thing that causes binding. Well, sure, but then you cannot solve the boundary problem because everything is entangled with everything else, except that some things are much more entangled than others, but essentially it's a gradient. And like so there's no hard boundary where you can say, okay, these two things are actually not entangled with each other anymore at all. And actually everything is just a gigantic network of entanglement. So there's no boundaries. Okay, so that's not gonna do it. And then other people like Jojo McFadden or Susan Pocket would essentially say like, yeah, it's electromagnetism solves the binding problem because it's inherently unified. But then they lack the extra step of, well, how do you get the boundaries then? And so I would say that, yeah, this is kind of like a new contribution to the conversation.
Okay, and so then there's this other facet. This is also compatible with the modern scientific world picture.
Yeah, which means that, yeah, the brain is not somehow doing something new that is not captured by the standard model or whatever, like, like future physics update on the standard model. I'm assuming the standard model is like pretty close to the truth. And so like you don't require new physics is the main point. It is, however, like a different view than like, let's say like everything is computational because such as in quantum mechanics, like, well, yes, actually you may not be able to create a Turing machine or a cellular automata that actually implements this thing where like an electron is going through all of the possible paths simultaneously. That might be computationally intractable, but that's still physical, right? Like that's still just following Schrodinger's equation of quantum mechanics. It's mathematically precise and causally closed.
All right. And the sense here is also that if you used our current scientific picture to model simply how all the neurons were firing, that would be insufficient for understanding what the human brain was doing because it wasn't also incorporating how the local field potentials of the neurons aggregated into a global field and how that was useful for computation.
Yes, exactly. If you use a simplified model of the brain that is just taking into account neurons and their synaptic connections and essentially, yeah, this differential equation of how, what does the spiking of the neuron look like, that is going to be missing essentially the entire field of research called emphatic coupling, which is how neurons can communicate in non-synaptic ways. And that is, yeah, essentially using fields. I mean, you would probably be very interested in this perspective, which is that, in this account, that like, okay, actually your experience is this patchwork of local field potentials creating a topological pocket. This explains what influence consciousness can have in behavior and the brain. Because what research shows is that local field potentials, they don't change neural activity directly all that much. They don't make a neuron fire, but they do, but very little. The thing that they do a lot is they increase the probability that neurons will fire in phase or in a state of coherence. And the simplified version would be that it increases the probability that neurons fire in synchrony. And so when you're paying attention to something, in this view, is like you're adding this local field potential in that region of the brain that represents that something, and you're making the neurons there more likely to fire simultaneously. I think this is like pretty obvious from like meditation, and like this would be another very fun exercise for anybody to try. Like literally pay attention to any two regions of your body, like let's say your toe and your eyelid or whatever, and keep your attention there on those two places simultaneously. If you do that for like, let's say 5 minutes, I guarantee you will start noticing how they're synchronizing and how they actually start to kind of like vibrate in the same way. That is the effect I'm talking about. That whenever you're spreading your consciousness in two representations at once, you start to have like synchrony between them. And so, yeah, this also explains like epiphenomenon, like how we're sidestepping epiphenomenalisms. Yeah, actually the consciousness is doing something helpful, which is helping neurons to synchronize with one another.